Hello and welcome to another StudyingWorks lesson. Today I'll be teaching you how to determine equilibrium concentrations in molarity using a method called the ICE chart. ICE stands for Initial, Change, and Equilibrium and is quite simply used to find concentrations of substances at equilibrium. First, write the equation at the top, and then from there you add what is given and solve for the rest. To understand this, let's try an example. If 0.2 moles SO3 is placed in a 0.5 liter container, it is found that 0.05 moles oxygen is in the container at equilibrium. Determine K, equilibrium constant, for this reaction. First of all, let's write out the equation. So now we're going to need to find what we're given. We are given the moles of SO3 placed in the container, the moles of oxygen at equilibrium, and also the volume of the container. This means that we can find the molarity of these two substances. So first of all, let's find the molarity of SO3. SO3's molarity will be 0.2 times 2 because it's 0.2 over 0.5 liters. So this will be 0.4. Now the oxygen is 0.05 moles. However, it is at equilibrium, so we need to add this here. And then the rest of the concentrations at the start will also be 0. So from here, we need to determine what the change is, the C in ICE chart. So the change in oxygen will be plus 0.1 molarity, because in order to get from 0 to 0.1, you have to add 0.1. However, based on the mole ratios, you can tell that there's 2 moles of SO2, so this means that we have to do plus 0.2, multiply it by 2. And it's the same with SO3, however, it's on the product side, so we actually subtract. And then from here, you can get your answers. Your answers will be 0 plus 0.2 is 0.2, and 0.4 minus 0.2 is also 0.2. Now to determine the equilibrium constant, we have to actually create the equilibrium expression. So K is equal to the products over the reactants. So product is SO3. Then as the coefficient is 2, we have to square it. And then the reactants are SO2 and also squared times O2. So based on this, we can simply add the values from the equilibrium section of the chart, as this is the equilibrium constant. So therefore that is equal to. So from here we can just calculate that, and this will give us 10.